3D printing. What is it and why is it so important? Stick around and I'll show you. 3D printing, also known as additive manufacturing, is the method of creating a three-dimensional object layer by layer using a computer-created design. 3D printing is an additive process whereby layers of material are melted to create a 3D part. My 3D printer, the Ender 3, is a very popular 3D printer. This is because it is a cheap and open source 3D printer, which is easy to upgrade and customize. Some very common materials used with the Ender 3 are PLA, PETG, and TPU. PLA, also known as polylactic acid, is a plant-based product used as a very brittle but easy to print material. PETG is a little bit more difficult to print, but is much more withstanding to high temperatures. And TPU, which is thermoplastic polyurethane, is a very flexible material. 3D printing can allow you to make anything you want, anything from your imagination. All you have to do is design it, such as in Inventor or Fusion 360. 3D printers are like humans. They're just too stupid to understand simple commands. So, we have to give it to them in a language that they understand. That would be G-code. G-code is similar to coding, but it tells the 3D printer to move certain parts within a printer to print the file. The G-code file is created from the slicer. The slicer takes an STL file from your 3D model and converts it into a G-code file. 3D printing in itself is not that difficult to do. All you need to do is take a 3D model design and import it into a slicer. A slicer takes a 3D model and is basically the roadmap of the 3D printer to 3D print the item. It takes an item such as this little box that I got from Austin LaMonaco. It takes this, you can set your standards. Now all you have to do is slice, preview, and then it gives you this. This is a view of the path that the toolhead will follow when creating the 3D object. When we go down the slider, we can see all the layer lines being put into place, as well as the infill. If we zoom in, we can see that we have one outer wall, one inner wall on both sides, and then we have our infill. The slicer takes a 3D object and turns it into basically a roadmap for the toolhead to follow. The toolhead creates the 3D object by melting a hot plastic, such as the PLA, and lays it on top of itself over and over until the object is made. This is also how additive manufacturing is. This is the definition of additive manufacturing, such as adding a material on top of itself over and over, versus where in CNC machines where you would subtract, like a lathe. Alright, so now that I've explained how 3D printing works and how do you do it, I'll go into detail about some of the upgrades that I've done on my own 3D printer. When it comes to 3D printing, there are some basic steps that you must do. For example, you need to have a level bed. Keeping your bed level is important for running a 3D printer. If your bed is not level, your 3D printed plastic will not stick in some places and will peel off the bed plate. This can result in a failed print. So, the first two upgrades that I did in my 3D printer were a BL Touch auto bed leveling system and an SKR Mini E3. The BL Touch works with the SKR Mini E3 to auto bed level my system and tells me where I need to raise or lower my 3D printed bed. The SKR Mini E3 from Big Tree Tech makes my 3D prints a bit more detailed while also keeping the stepper motors a bit more quiet. The Ender 3 when you first buy it is a bit loud, especially with the stepper motors making the whole thing vibrate and the fans being very loud. So, with this, we don't have to include any new motor drivers to keep the motors from vibrating the entire 3D printer, as well as you're able to include the BL Touch sensor. After I was done with that, the next few upgrades I did were from Microswiss, specifically the direct drive extruder and the all metal hot end. The direct drive extruder moves the extruder stepper motor away from the edge of the 3D printer and onto the very top of the tool head. This allows the 3D printer to 3D print much more flexible materials while also reducing stringing. Of course, the added weight also has to be accounted for, which I'll explain in a minute. The all metal hot end allows the material to be melted at a higher temperature, as well as being able to be melted at a quicker rate. The added weight on the X gantry from the Microswiss direct drive also causes the X gantry to sink on one end. And so, to solve this problem, I used a dual Z-axis system. The dual Z-axis kit allows me to put two stepper motors instead of just one to lift the X gantry up along its path. Another thing I bought for my 3D printer was a glass bed. Glass beds are very flat, which is very nice for 3D printing. Especially with flat materials, you're able to have a more consistent bed level. I also changed the fans on my 3D printer. I added silent Noctua fans, which keeps the 3D printer from being loud at night. And I also added a blower fan. This allows the tool head to be able to cool the filament as soon as it comes out of the hot end. This allows the 3D printer to have better bridging, which is 3D printing in the air, and also allows the 3D printer to print at a faster rate. And finally, the most important upgrade to my 3D printer, in my opinion, would be Octoprint. Octoprint allows you to wirelessly control your 3D printer, view your prints over a webcam, upload files to the 3D printer, record time lapses, and you can even upload your own G-code to the printer. In the future, I'd like to make my 3D printer a bit more reliable, as it keeps breaking down as I add more upgrades. I'd also like to try new filament materials, such as ASA. And of course, I would like to continue to enjoy 3D printing. Thank you for listening, and have a great day.